Hello, I'm Brian Cohan. I'm with PBD Tools, a new software solution company aimed at making fire modeling a lot easier. Thank you to Thunderhead for setting up with a couple great presentations to lead into my talk. I've been doing modeling for about 15 years or so, and I've developed a bunch of different tools to help me do my to do the modeling. And one day I just kind of realized that streamlining the workflows and reducing the errors in the modeling was a more interesting problem to solve than the project itself. So I'm sure we're all familiar with FDS. Just by a show of hands here, feels that they're comfortable seeing a small snippet of FDS code and can interpret what's going on? All right, cool. Right conference. So I have a snippet of code on the next slide, and there's 3 questions. And when you get the answers to all 3 questions, I want you to raise your hand and let me know that you got it. Given this FDS code, what's the mesh shell size? What's the peak heat release rate? And is it fast, medium, or slow growth fire? I'm sure you can tell all the information is there to figure this out, but it takes time to understand the FDS code. So, I mean, it's not terribly hard to understand it, but it takes a while. So what do? We build tools, like some spreadsheets. This is a spreadsheet I built to put in a bunch of different tenability devices, so I knew that they were all consistent in the same location. I could reference cells, so I can say if I need to change my Z elevation, then I can change it in one spot and it propagates everywhere, and it was great. But what if you need to modify this and add in new rows or delete some lines? Then that's going to be a tedious process to update. And you might have assumptions in the spreadsheet that don't translate well to the next project. So say, OK, let's get a little bit smarter here. And I would write some stuff in Python. And this actually helped burn through a ton of contracts, series of buildings that were all very similar, and allowed me to get the modeling time by the end of this series of projects down to, or from getting the documentation and notice to proceed, doing 3 fire models, or 3 different design fires, egress model, writing the report, all to be ready for review for the project manager by the end of the week. But when the template building got tweaked a little bit, this got really hard to maintain. And look at all these different files that I had to maintain just to automate all this stuff. Even worse is now the documentation is stored in these files, not in your FDS file. And they might not be as user-friendly as we think they are. I know only a few people in my company know how to use Python. So I can't hand this off to any junior engineer doing fire modeling. So allow me to introduce xFDS. It is a free, open source, progressive, extendable, and general purpose framework for rapid model development. When I say free, I mean free as in free beer. Progressive, you can start small and work your way up as you get more comfortable with the concepts of how to use it. And it's extendable. There's some features in here where if there's something not ready or you need a different filter in your model, you can go ahead and program it in there without having to wait for a future release. It also is great for helping build custom things for specific projects. It's built on these 3 philosophy points. 1, there should be a single source of truth for all your data, not scattered across a bunch of different spreadsheets or other calculation tools, just one spot. The user should also be able to understand the differences between all the models that they have on their machine without navigating a ton of menus or opening up a bunch of different files to see did I do everything correctly. And lastly, the user shall be productive without having to be a developer. Leave that to this corner of the room. So let's revisit the question before. We got the XB coordinates, which gives you your X, Y's, and Z's and your spatial dimensions. And the IJK tells you how many cells are in each of those 3 cardinal directions. Kept it simple at the origin to make the math easier, but you do the math and you find out that this is a 15 centimeter mesh. That was 6 different mathematical operations that you would have to do just to get this answer. But what if you, instead of writing this, you could write a template file that looks like this. Now you'll see here I set different variables, and then down here we're actually going to use the variables. So the curly braces with the percent sign is telling this template system, set this variable. And this is a 20 by 12 foot room, and this pipe and then convert, that's a filter saying, hey, take this value, convert it from feet to meters. You don't have to do this conversion anywhere else. It just happens for you right here in the template. The resolution, so that's 15 centimeters. Makes it nice and clear what's going on. And then we say, let's take this dx value, put it right there, dy goes there, dz goes at the end. You want to calculate your IJK, take your dx, divide by your resolution, make sure it's an integer, you're ready to go. Do the same for the rest of it. So this is self-documenting, it's clear what the intent of the code is here, and it's kind of unambiguous. This is a lot of writing, so we've also added some convenience filters. This is where I will define bounds as a sextuplet that I can pass in directly to the XB parameter. And then this XB filter just makes it print nicely for fixed width columns, so it's easy to read the final file. But you can also pass this bounds parameter or variable into the IJK filter, tell it your target resolution, and it will give you your IJK up there. You want to change your resolution, all you have to do is change this number right here, and the rest of this will recalculate for you. You want to extend your domain, you don't have to worry about recalculating your IJK. So, as Donna mentioned earlier, what do we do with our meshes? We need to do a sensitivity analysis. So you'll see over here on the left is a similar template. We got the bounds variable going into the mesh line, and a surface defining a fire. Over here is a configuration file telling xFDS how to render this template. You give it a name on how to name the output files, and that is also the same template syntax used over here. Tell it what files, model.fds would be that template name over there. And you can include multiple files if you need to, and we'll get into why in a bit. I moved the dx, dy, and dz definitions out here just to show that you can also define them there if that's easier to have this be a at a glance for what's in your model. Set the area for the burner, and then I have 2 different parameters just because that's all I could fit on the slide. But as Voracek mentioned, you can have thousands of scenarios that you need to generate. So this will actually take these 2 parameters and give you every single combination. And you can see that the resolution gets put in that one spot. The heat release rate gets used in 2 different spots, do these calculations automatically. So when it produces all these different fire models in their own folders with their same names, I know that if I look into that 1500 kilowatt at 0.15 meter file, that's what's in that file. I don't have to worry about, did I copy it over correctly? Did I get my mesh right? I'm not having to look at every file, comparing it. I know what's in that file because it came from this template. What about the peak heat release rate or the growth curve? Well, you can take your x's and y's, calculate the lengths of those, get your area, multiply your area by the heat release rate per unit area, and you get, this is a 1,250 kilowatt fire. And you can do the math to find out it's a 300-second growth curve, which is a medium growth fire. But instead of writing this FDS code that's a little hard to parse and you have to do the calculations for, you write this template file, where right there in your model, you're saying, set my fire to be 1,250 kilowatts. Set my fire to be located at this location. I want the area to be 1.5 meters squared. And then I can calculate from that center point, how far in each direction do I need to go to make sure that this vent matches the heat release rate per unit area. So here in the FDS lines, I say my heat release rate per unit area is the heat release rate divided by the area. Follows a growth curve, or tau Q value, with that target heat release rate following a t-squared growth curve with a characteristic growth time of 300 seconds. This will also accept an alpha value if you prefer to use those. And then because my XB parameter on this vent is set from a calculated value, I know that these two will always be in sync and give me the intended heat release rate. So there's a ton of other features that clearly don't have time for, but you can generate a whole ton of scenarios with this. There's a mechanism in the configuration file to say, if I have this heat release rate and this exhaust rate, then I want to add this other information in there, or you can also tell it to exclude it. In your template file, you can also create reusable template blocks. So if you need to define something like an HVLS fan or a door leak that takes multiple FDS records, you can create a function in there to make sure you have the same template code over and over. And you can also use if statements and for loops to iterate and toggle things on and off. Extendable. If you know Python at all, then you can create this filters.py file, put it right next to your configuration file. And any function that is defined in there will immediately become a new filter that you can use in your project. And then you can copy those and take them from project to project if you need to. Or if you need to define some custom units. For example, the underlying library that does the unit conversion for me didn't know what CFM meant, and that's something very common. So I told it, hey, CFM means feet cubed per minute. And now I can use CFM as a unit to convert to and from. Other great things, like I said, you could add in a bunch of files. So if you do a bunch of smoke view scripting, then you can toss those in and they'll be treated like templates. Or if you need to create PBS files because you're running this on a large compute cluster, you can create a template file for your PBS and you'll get that exported individually for every single model that gets rendered. Now I know there's a lot of different ways to create an FDS file. But I do think that xFDS can help improve your workflow. I'm not saying this just because they're there, but I do use PyroSim as well in conjunction with this because this spits out the text file and it's nice and easy to upload it to PyroSim and say, okay, I got it right. But whether you're the person developing the fire model, the person reviewing that fire model before, to approve it, or if you're the third-party reviewer who doesn't know much about a given project. If you're not sure if it's really worth the time to learn this tool, then I have another test for you. 3 questions. I would love for you to raise your hands once you think you have the answers. Given this FDS template code, what is the mesh cell size? What's the peak heat release rate? And is it a fast, medium, or slow growth fire? Anyone? Brian's got it. Yeah, so it's all right here in your file. Self-documenting, self-calculation. You don't have to worry about copy and paste errors or anything like that. And to me, this has just made FDS a lot easier to work with. So thank you for your time. I know it's a valuable resource. You can check us out at pbd.tools. This project is documented at xFDS.pbd.tools. There's a couple examples in there. It's open source. You can check out the repo. Connect with us at pbdtools./connect. That will give you links to YouTube, Twitter, my personal LinkedIn as well. So thank you.
Great. Thank you, Brian. Any questions from the audience? No? I did see a lot of photos of your QR, so expect some traffic.
That's a good feeling.
Yeah. Let me come back here. QR codes are the secret sauce to big, giant presentations. It's good.
Hi. So disclaimer, I never used FDS, so I kind of don't care about ini files. But this sounds really like a very interesting idea to template the ini file because you don't want to do copy-paste and there is some logic in it. I like it. But why did you use YAML, this format, and not like stick with Python and use something like Jinja library?
So this is actually Jinja.
Okay.
Jinja is the underlying template system for this.
Okay, that's cool. Yeah. So you process the whole with Python still?
Basically, all xFDS is a way to read in, this part of xFDS actually, because it can also do more stuff than just render your templates. It's basically saying, oh, let's go render this one template, and I've built in certain filters to go with that, so those go include into the rendering environment. And I made it so you could also create your own filters for your project. Does that answer?
What I wanted to say is, now you have this template, and from this template you kind of need ini file for FDS. So what is the processor that makes the transform the template in the ini file?
So here, so xFDS, when you call it the render function, looks for this pb.yaml file. In here, relative to this document, it should be in the same directory. It says, let me pull in model.fds, which is that. So these two files would be in the same directory together. So given this location, it knows, okay, let's load that in, load these variables, and it will just.
Okay, so this is now easy to use, and probably it will save you a lot of effort in editing those ini files, hopefully. But then, do you have some constraints and some checking for errors in your template? Like here, for example, you have dx in feet, but area in meter square. So I mean, I can imagine a user can mess up quickly and run something which is what FDS doesn't like. And before I start running FDS and then figure out, oh, it's not working, do you have something in between that catches those errors?
Not with this tool. This is the first of many tools that I hope to develop, and one of the tools that I'm aiming for will be able to identify certain errors where you might have mixed up units or specified something wrong, because I've had many issues like that in my own models. And this helps kind of eliminate, but it's still, we can only go so far as to make sure your model is correct. We can just help you write it faster.
Yeah. Thank you. It's a very nice idea.
Thank you.
Yeah, some kind of linting tool like you mentioned that can sort of check for sanity and make sure things add up. And yeah, that's a good idea. Anyone else? Yeah, here in the back.
Hi there. Yeah, this looks really, really cool. One thing you didn't really elaborate on a lot is what the functionality is in terms of smoke view. Would you mind just explaining what the sort of things you can do?
Oh, with the talking about this? Yeah. So if you notice the Vortex smoke view slides all had like the consistent aspect ratio and all that stuff, you can set your smokeview.ini file with certain parameters, so that as soon as you open up SmokeView, it's going to load that and say, okay, you want this to be this tall, this wide, have this view, turn on this slice, you can, all that stuff. Or turning on and off slices is actually in the SSF. So there's a lot of configuration that you can tell SmokeView in the ini file of what to do when it opens. The model.ssf will allow you to script the output from SmokeView. So you can tell it, you know, I want to, these are my floor elevations. I want to get the visibility across the floor and get those all pretty quick. So if you know how to write the SSF script file, and it's all documented in the SmokeView user guide, you can make it faster using this template system and also put it in that folder directly. It will have the same name, which is what SmokeView is going to look like for. And it's just there. So you could batch run all your SmokeView scripts. Thank you.
Okay, one question here, how can we access xFDS? Is there a technical guide to it, though, through which we can understand it better? I think you have the URLs on the last slide, so this is a good...
So xFDS.pbd.tools will take you to the documentation. It explains how to write the template files and the options that are available in the configuration file. There's some special topics that one of them will tell you how to write the PBS files if that's something you need. And in the top right corner of that page will be a link to the GitHub URL, actually. If it's okay. Please work. So yeah, here's some notes on how to install it, how to generate the files, the configuration.
Yeah, that's great.
It goes the other way. You can see the custom filters that I've already kind of built in here and some more examples of the code. This kind of explains the render and how it all works.
Excellent.
And you can even play with GFast.
There's a question here. I'd like to see xFDS to be bound by some subroutines. One, for example, is for dump files, miscellaneous, React file sets. So we can cut and paste the entire Fire script to set up easier, because it would give some flexibility to prepare files that can be repeatable and just switch up these subroutines efficiently. So do you have something, that capability?
Can you read the first part of that again?
Yeah, just it sounds like some kind of subroutines for specific sets of nameless groups like dump or miscellaneous or reaction. Yeah. So you can just cut and paste almost like a library, maybe macros, I think you mentioned.
So
like this.
In the examples folder, like filters, where's the filters.py file? Or no? Never mind.
Yeah, maybe.
No, these are actually, all right. So there's,
if you could reply maybe to that with some links or examples, that would be great, or to follow up. Yeah,
you can create your own macros that you can copy that macro to a new project if you need it, or hopefully I'll unlock the ability to import other files as well within your script. And yeah.
And I think one nice thing that you can see here, since it's on GitHub, is there's an issue tracker. So people with feature requests or anything, they can put it there. Is that a good place?
Yeah.
Okay, great.
All right.
All right. I think that's it. So with that, thank you very much, Brian.